Approximating trig expressions using partial sums. So fun. Let's get into it. So, something that's really important to remember when we're looking at these representations of the trig functions as power functions is that sine is odd and cosine is even. So, with sine, we always start with 1, but x to the first power divided by 1 factorial, well, those just don't really matter, so they're not written. So it starts like that, then we move to the next odd number, x to the third over 3 factorial, then the next odd number. And what's really important to remember is that we always start by subtracting and then alternate from there. Addition, subtraction, right? Only using odd powers, odd denominators. So then when we get to the cosine, well, cosine's even. So if I had x to the 0 power divided by 0 factorial, remember 0 factorial is 1. X to the 0 power is also 1, so that's why we're starting with a 1 here. Then, same as sine, we're starting with subtraction, then alternating every other sign from there. So, let's look at cosine of pi over 3. Well, cosine of pi over 3, y'all started to know that from the unit circle, but cosine of pi over 3 should be 1/2, right? We already kind of know the answer to this one, or we do already know the answer to this one, but now we can approximate it using this long method. So, starting with 1 minus x squared over 2 factorial. Well, x is pi over 2, pi over 3, squared over 2 factorial. Switch to addition. Next even number, pi over 3 to the 4 over 4 factorial. Switch the sign. Pi over 3 to the 6th over 6 factorial. And that's 1, 2, 3, 4 terms. Then, when you go to plug this in your calculator, make sure you're being careful. You're putting that pi over 3 in parentheses, then putting it to the power. Some people like to go one at a time. I just throw it all into one line. And for this one, I got 0.49996. Yeah, if I rounded that, it'd be 0.5. So, we know we're right. Let's take a look at sine of 3 pi over 10 next. Sine of 3 pi over 10, we start with just the value. Always subtract first, then to the next odd number, right? Technically, we're starting with a 1 there. Now on to 3 pi over 10 to the third over 3 factorial. Switch to addition. 3 pi over 10 to the 5th over 5 factorial. Switch to subtraction. 3 pi over 10 to the 7th over 7 factorial. And you plug that all in, you waste a little bit of time plugging and chugging in the calculator, and you get 0.809. And I did check my answer to make sure I did it correctly, and it is, when we round sine of 3 pi over 10 to 3 decimal places, we get the same exact answer. How cool!